In this video, we will talk about object-oriented programming. We have already seen and used objects in Python. Using object does not mean object-oriented programming. For object-oriented programming, we need to look at the concept of class. A class consists of a set of variables or data attributes and methods that define a type of an object. Let us consider an example of a box class. We can have length, breadth, and height of a box as the data attributes or variables of class, and we can have methods as to compute the volume of the box as well as compute the area of the box. In any object-oriented programming language, there are three fundamental features: encapsulation, polymorphism, and inheritance. These features differentiate between object-oriented programming and procedural programming. Encapsulation is a mean of bundling together instance variables and methods to form a given type. For example, we have already seen a box class. The selected members of the class can be inaccessible or hidden, and this is referred as information hiding. For example, the variables length, breadth, and height of a box can be hidden inside a box class. The information hiding is a form of abstraction. We will talk about polymorphism and inheritance in the coming lectures. Let us now look at how classes are defined in Python. Let us take an example of defining student class. The class keyword is used to define a class in Python. This is much the same as def keyword, which is used to define functions, followed by the name of the class, that is in this case student, followed by a colon. All the statements within the class declaration are indented, just the same way as the statements of a function. After defining the class header, that is class student, we can use a document string, and class will have data attributes or variables and methods. The data attributes are classified into three types, that is instance variables, static variables, and local variables. As well as the methods are also classified into instance methods, static methods, and class methods. The class methods are not available in other programming languages. It is specific to Python. The instance variables are object level variables, static variables are class level variables, and local variables are method level variables. The class student is a class header which defines the name of the class. The string in triple quotes is known as documentation string or doc string. Providing documentation string or doc string is optional. In the next lecture, we will practically see how to define a class in Python and how to create objects of that class. Let us define a student class. We will use a keyword class to define a class. And let us give the name of the class as student, followed by a colon. We will have a doc string. Let's say this is version 1.0. We will create instance variables and initialize them. Instance variables are initialized in the init method. To define a method in the class, we need to use def as the keyword, just the same way as defining functions. So we will use def underscore underscore init underscore underscore and provide self as the parameter. This method is called constructor. It is a special method which is implicitly called when object is created. In Python, instance method must have an extra first parameter, by convention named as self. This parameter contains a reference to the object instance to which the method belongs. Self is a pointer or reference to the current object. We will create an instance variable using self.name and assign the value as John. We will create another instance variable using self.role and assign the value as 101. We will also have the third instance variable using let's say marks, and assign the value as 78.25. Here in this case, name, role, and marks are the instance variables. In a class, any variable defined using the self is an instance variable. The other special method is an str method. So we will define str method using underscore underscore str underscore underscore and self as the parameter. This method is used to represent the value of an object as a string. So this method returns, let us say this is student class. To create an object of the class, we can use reference variable equal to the class name, followed by parenthesis. In this case, we will use s equal to student, followed by parenthesis. where S is the reference variable and student is the class which we have defined. Do remember that the statements within the class are all indented and the statement S equal to student is not indented, therefore it is not part of the class. The reference variable S can be used to access class variable as well as class methods. For example, we can use print S dot name, which is an instance variable. We can also use print S dot roll, as well as we can use print S dot marks. Let us execute this program and trace the results. In this program, we have defined a class student. Using the statement S equal to student followed by parenthesis, we are creating an object S of the class student. When we create an object using the class name, the init method is automatically or implicitly called. This method is known as a constructor, and constructors are used to initialize instance variables. The init method or the constructor is initializing the instance variable name with the value John, the instance variable roll number with the value 101, and the instance variable marks with the value 78.25. Therefore, once the object is created, the init method will be called implicitly and instance variables are initialized. In these three statements, we are using reference variable, that is S, and we are accessing instance variables such as name, roll number and marks. Since we have them in the print statements, we are getting the output as John, that is the value stored in the instance variable name. Then we have the output as 101, which is the value assigned to roll, as well as we have the output as 78.25, which is the value assigned to the instance variable marks. Let us now try to access the doc string. To access document string, we can use print statement followed by the reference variable, that is in this case S dot underscore underscore doc underscore underscore. Let us execute this program. You can find that this is the document string, which is displayed as the output. We can also access the special method str using the print statement. For example, we can use print of S, which is a reference variable. Let us execute this program and you can find that the string which is returned through the str method is displayed in the output. In this students class, we have seen the init method as well as the str method. These two methods are special methods. We can also have user-defined methods. For example, let us create a method as display, which displays the values stored in instance variables. This method display is also known as instance method. In Python, both functions and methods are same, except that they are differentiated only based on their position. The function is written outside the class, whereas method is written inside the class. For instance methods, the first parameter should always be self. Self is implicitly provided by Python. So therefore, in this instance method display, we have a parameter as self. Let us have print statements within the body of the display method. For example, print student name, comma, self.name. When a method accesses any other member of the same class, the member name must be preceded by self. So therefore we are using self.name to access the value stored in the variable name, which is an instance variable. In the same way, we will have print roll number, comma, self.roll, as well as we will have print marks, comma, self.marks. Now this class has three instance variables, that is name, roll and marks, as well as two special methods, that is init and str, preceded and succeeded by double underscore, as well as an instance method, that is display. We have already created an object S or reference variable S of the student class, and instead of accessing instance variables through the reference variable S, we can call the instance method display using the reference variable, that is s.display. Let us execute this program. You can find that we have this as the result, since we have created an object of student class and called the display method of the student class using s.display. When display method is executed, we have the print statement that displays student name as John. The second print statement displays the roll number as 101, and the third print statement displays the marks as 78.25. The values of instance variables, that is name, roll number and marks, are already initialized through the init method, which is implicitly called when the object is created. Let us revisit the class students constructor, that is the init method. Here in the init method, we have initialized fixed values to instance variables. So any object created will have the same values for instance variables. For example, let us create an object S1 of student class, as well as S2 of student class, as well as S3 of student class. So here we have created three objects S1, S2 and S3. Let us call display method for object S1 as well as the display method for object S2 and display method for object S3. Let us execute this program. You can find that the display method of all the objects, that is S1, S2 and S3, is displaying the same result. This is because we have initialized fixed values to the instance variables. To initialize different values for different objects, the constructor may also have other parameters. For example, let us use init. The first parameter would be self. The second parameter, let us call it as name. The third parameter, let us call it as roll. And the fourth parameter, let us call it as marks. And in the next statement, we will have self.name and assign the value as name. Self.roll assign the value as roll. And self.marks assign the value of marks. Here, the name, roll and marks are parameters. And self.name, self.roll and self.marks are instance variables. We can now create objects and assign different values to instance variables. For example, we can use S1 equal to student and let us pass the value as AAA, 101, 78.25. For object S2, let us pass the values as BBB, 102, 62.55. And for object S3, let us pass the value as CCC 103, 87.45. Let us now use the statements S1.display, S2.display as well as S3.display. Let us execute this program. You will now be able to find different values displayed for instance variables of different objects. This is because the constructor now have 4 parameters, and when creating an object S1, we are using student and passing 3 arguments. That is the string which is passed to the parameter name, followed by the value 101 which will be passed to the parameter roll, and the value 78.25 which will be passed to the parameter marks. In the same way, we are also initializing the instance variables of the other 2 objects, that is S2 and S3. If you observe, when we are creating an object, we are passing only 3 arguments. This is because the self parameter is passed by Python implicitly. In the same way, when we are calling the display function, though the display function has one parameter which is self, but since self is passed implicitly by Python, we do not pass any argument when calling the display function. Instead of creating 3 different reference variables or objects, that is S1, S2, S3, we can create a list of objects. For example, we can use S equal to, within square brackets, we can create the first object, second object, as well as the third object. So in this case, S is a list containing 3 elements. All the 3 elements are the objects of student class, and instance variables of each object is assigned different values. And instead of calling display method multiple times, we can use a for loop for, let's say, I in S. We can call I.display. Let us execute this program and we get the same result. When the for loop executes, for the first time, I will be representing the first object and we are calling the instance method display of the first object. Subsequently, the for loop will call the display method of the second object as well as the display method of the third object. In this video, we will take a look at how init method is called. Let us define the same student class using the class keyword, that is class student, and then let us have an init method, that is def underscore underscore init underscore underscore, and then have the parameter as self. We will have three instance variables, that is self.name, and assign the value as abc. We will also use self.roll and assign the value as 101, as well as we will use self.marks and assign the value as 78.25. Let us have an instance method, that is display, and this method also will have one parameter, that is self. We will have a print statement which will print the value stored in the instance variable name, as well as comma self.roll comma self.marks. We will create an object of this students class using s equal to student. In the students class, we have a method init. It's a special method, and this method is automatically called when the object or the reference variable is created. The init method works as a constructor. Always remember that the special methods are preceded and succeeded by double underscore. We will execute this program. You will not find any output displayed. But when we create a reference variable or object of the student class, the init method is implicitly called. So therefore, to get the feel of implicit call, let us try to have a print statement within the init method. We will print a text, let's say in constructor. Let us now execute this program. When we execute this program, you can find that we have the output as in constructor. This is because once the object is created, the init method is automatically or implicitly called. And in the init method, we have a print statement. So therefore, we have the output as in constructor. We can also call constructors explicitly, and it is same as calling any instance method of the class. So we can use the reference variable s dot and the method, that is double underscore init double underscore, without passing any arguments. So now when we execute this program, you can find that in constructor is the first line displayed. This is because we are creating the object and init method is implicitly called. Once the object is created, that is s, we are explicitly calling the init method. So when we explicitly call the init method, we have the second output as in constructor. So remember that the init method, which is a special method or a constructor, can be implicitly called when the object is created, or it can also be explicitly called using the reference variable with the init method. In this video, we will look at how to initialize instance variables without using the init method. Let us create a class student. In this class, we will not have init method, but we will define the display method, which takes in only one parameter, that is self. And we will print and use the instance variable self.name. We will have another print statement which prints roll number, and we will use self.roll as the instance variable. We will have another print statement, print marks, and we will use self.marks as the instance variable. We will create an object of this class, that is s equal to student. If you observe, the class student does not have the init method. Let us call the display method using the reference variable, that is s.display. Let us execute this program. You can find that we get an attribute error which says student object has no attribute name. We are using self.name, but we have not initialized these variables. Since we have not initialized name, role as well as marks, at this point of time, these instance variables do not exist. So before calling the display function, we need to initialize the instance variables, that is name, role and marks. We will initialize these variables without using the init method. So therefore, we will use s.name and assign the value as John. We can have s.role and let us assign the value as 101, and s.marks, let us assign the value as 78.25. Now let us execute this program. You can find that we get the output without any errors. Since we have initialized the instance variables and then using the display method, we do not have any errors. So this is one way of initializing the instance variables using the reference variable or object of the class. The other way of initializing the instance variables is through an instance method. So we will create a method, let's call it as init. And we will have the first parameter as self, the second parameter as name, third parameter as role, and fourth parameter as marks. Now here we will have statement as self.name, which is assigned the parameter name, self.role, which is assigned the parameter role, and self.marks, which is assigned the parameter marks. Here, instead of using the reference variable or the object, we will call the init method, that is s.init, and then pass the arguments. Let us pass the first argument as John, the second argument as 101, and third argument as 78.25. Let us execute this program. You can find that we get the same result. This is because the object S of student type is created and we are calling the init method of the object S. This init method is not the constructor or the special init method because it is not preceded or succeeded by double underscore. So this is the instance method, not the special method. And in this method we have 4 parameters, that is self, name, role and marks. And we are passing 3 arguments. The first argument John will be assigned to parameter name. The second argument 101 will be assigned to parameter role. The third argument 78.25 will be assigned to marks. The self parameter is by default provided by Python, which is the reference to the current object. This method, which is initializing the instance variables, can have any name. For example, we can use assign as the name and then call s.assign. Let us execute this program. We get the same result. So this is another way of initializing instance variables without using the special init method. Do remember that the instance variables has to be initialized before they are used. In this video, we will learn more about the self parameter of the instance methods. We will consider the student class. In this student class, we have the init method. This init method is preceded and succeeded by double underscore, and it is a predefined method also known as the constructor. This init method has 4 parameters: self, name, role and marks. The first parameter is always self. We also have a display method, and this is the user-defined method, which is an instance method. This method should have one parameter, that is self. So every instance methods will have at least one parameter, which is self. The self parameter is implicit default parameter provided by Python, always pointing to the current object. By using self, we can access instance variables or object variables and also instance and object methods. The self parameter explicitly have to be declared as the first parameter in every instance method. When we have created an object or the reference variable, that is s equal to student, we are passing 3 arguments, but the constructor has 4 parameters. The self parameter is implicitly provided by Python. And we do not pass self. Self is provided by Python. The other method displayDefined has one parameter, that is self. But we cannot provide self parameter, so when calling display method, we do not provide any arguments. The term self is not a keyword or reserved word in Python. We need not use first parameter as self. We can use any name. Python always considers first parameter as a reference to itself. For example, instead of self, I can use myself. And even in the body of the methods, instead of using self, I can use myself. Let us execute this program. We can find that we have the outputs of the values which we have provided. So whatever is the first parameter, it is internally treated as the current object's reference. It need not be self, but it is recommended practice to use self as the first parameter. Even in the display method, instead of using self, I can use ABC. And even in the body of the method display, instead of using self, I will use ABC. That is abc.name, abc.role as well as abc.marks. Let me execute this program. You can find that we do not have any errors and the output displays has the values which we have provided. So whatever is the first parameter, it is internally treated as the current object's reference. It need not be self, but it is recommended practice to use self as the first parameter. Do remember that self is not a keyword nor it is a reserved word in Python. In this video, we will look at how to access symbol table of the class. Let us consider a class student which has a special method known as init method as well as an instance method known as display. And here we are creating an object of the type student, passing values for the instance variables. Let us execute this class. Since we are calling s.display, we get the output through the print statements present in the display method. Let us try to look at what's a symbol table and how to access the symbol table. Every module has a special attribute known as dict, through which the symbol table of the module can be accessed. In the same way, even a class has a special attribute known as dict. So we can use the object or the reference variable, that is in this case it is s dot, and use the special attribute that is underscore underscore dict underscore underscore. This special attribute dict is a dictionary. Let us try to print the values returned by this special attribute. Let us execute this program. For the sake of convenience, I will have the run window on the bottom side. If you look at the output, we have a dictionary displayed, and this dictionary is used to store an object's attributes. Let us look at our program. We are creating an object s of the type student, calling the constructor by passing these three values, which will be assigned to these three instance variables through these parameters. So therefore, when the symbol table is accessed using s dot, the special attribute that is dict, we get the dictionary which includes all the reference variables as well as the values stored in these variables. So therefore, when you consider the first element of the dictionary, name is the instance variable which stores the value AAA, because we are passing AAA as a string to the parameter name, and the name parameter is getting assigned to the instance variable name. In the same way, we have the next element as role. Role is an instance variable which stores 101 as the value, as well as marks is another instance variable which stores the value as 78.25. Let us now use the reference variable or the reference object to change the value of the instance variable marks. Let us assign the value as 48.85. Let us again print the symbol table, that is the dictionary. Let me execute this program. You can find that the marks, which is the instance variable, earlier had a value 78.25, And this statement assigns a new value to the instance variable marks, that is 48.85. So when we are again displaying the dictionary or the symbol table, we can find that the value of the element marks is changed to 48.85. We can also create the instance variables using the reference object, that is s dot. Let us create an instance variable grade and assign the value as A. Let us again display the symbol table using the special attribute, that is dict. Let me execute this program. Now you can find that these elements of the dictionary or the symbol table are the same as the previous one. But since we have created another instance variable, grade, and assigned the value as A, the symbol table or the dictionary now has another instance variable, that is grade, which has the value as string A. Let us define another instance method and let us call it as profile, which takes only one parameter, that is self. And let us create an instance variable using self.city and assign the value as, let us say, London. Now this instance method profile is creating a new instance variable, that is city. Let me execute this program. You can find that none of the dictionary elements have city as the instance variable. This is because we have not used or called the profile method, and since the method is not called, the instance variable city is not created. Let us now call the profile method using the reference variable, that is s.profile, and then we will print the symbol table or the dictionary. Let us execute this program. Now the last print statement will contain element as city, which is assigned the value as London, because we have called the profile method, and this profile method creates city as another instance. We can also delete instance variables. For example, we can use del as the keyword, and let us try to use the reference object s dot. Let us delete marks. Let me once again print the symbol table or the dictionary. Let us execute this program. In the last statement of the output, you can find that we do not have the element as marks, since marks is an instance variable which has been deleted using the del statement. Let us create another variable within the instance method profile. Let us call it as states and assign the value as ABC. Let us remove these two statements. Let us execute this program. You can find that even though we have created states as a variable and assigned the value, it is not present in the symbol table or the dictionary. This is because since we are not using self to create states as the variable, it is not an instance variable. This variable is known as a local variable. The scope of this variable states is only within the method profile. And once the call to the function profile is made, the instance method profile gets executed. After completing its execution, the local variable states is no longer referenced in the memory. Therefore, when we are printing the symbol table or a special attribute dict, we do not have any element as states. So this is how you can use the special attribute dict to access the symbol table of the class or the object. Do remember that since dict is a special attribute, it has to be preceded and succeeded by double underscore. In this video, we will talk about static variables and local variables. Let us consider the student class. This student class has an init special method, which is called a constructor, which initializes all the instance variables. And we also have an instance method, that is display. This class contains three instance variables, that is name, roll number, and marks. The instance variables are object level variables. What this means is that every object created will have different values for the instance variables. Let us create object S1 passing these values for instance variables. Let us create another object S2 equal to student and pass some other values. For example, let us pass BBB for name, 102 for roll, and 55.65 for marks. Let us call display for object S1 as well as we will call display for object S2. Let us execute this program. You will find that the values for the instance variables name, roll, and marks are different for different objects, respective to the values which we have passed through the constructor. Static variables are class level variables. What this means is that the static variables will have the same value throughout every instance. Let us create a static variable with the name college and let us assign the value as UCLA. In the display method, we will have a print statement. Let us have a string as college name and we will pass the static variable that is college. Since this college variable is a static variable, we have to precede this variable with the name of the class, that is, in this case it is student. So we will have student.college. Now let us execute this program. You will find that the instance variables, that is name, roll, and marks, are different for different objects, that is S1 and S2, based on the values which we have passed. But the static variable has the same value for both the objects, that is S1 and S2. Please remember that when the static variables are used, they have to be preceded by the class name. And instance variables, when they are used, has to be preceded by the name self. There are other ways of creating static variables. For example, we can also create static variables inside the init method. But we need to precede the name of the static variable with the class name. For example, in this case we can use student.college and then assign the value as UCLA. Let us execute this program. You get the same result. So we can create static variables within the class but outside the methods, or we can also create static variables inside the methods but they need to be preceded by the class name. We can also declare the static variables outside the class. For example, I can use student.college equal to and assign the value as UCLA. But this has to be done before creating any objects. Let us execute this program. You can find that we get the same result. Therefore, static variables can be created within the class or it can also be created outside the class. Let us consider another scenario. Let us create a static variable within the instance method. That is, in this case, we are creating a static variable within the instance method, that is display. Let us execute this program. We get the same result. But suppose if we are creating a static variable at this place, let us execute this program. You can find that we get an attribute error at this line. This is because we cannot access static variables before they are created. So let us revert back the changes and execute once more. We get the same result. But suppose if we do not precede the variable with the class name and then execute the program, we get an attribute error at this line. This is because even though we have created a variable college, but this variable is considered as a local variable. And when we are accessing the variable college with the class name, that is in this case student, it is considered as a static variable. So therefore we are getting an attribute error. Now if we remove the class name, which is preceded before the college variable, and execute it, we will not have any errors and we get the same result. But in this case, the variable college is treated as a local variable and not as a static variable. And the scope of this local variable college is within the display method. Let us consider another scenario. Let us consider creating a static variable outside the class. For example, in this case, student.college and let us assign a string UTD. Let us execute this program. You can find that the college name is still displayed as UCLA, which is assigned in this statement. Now this variable college is treated as a local variable, and this variable college is treated as a static variable. But here we are only using the variable name. It is treated as a local variable. Therefore we have the output as UCLA. But suppose if we use student.college and then execute the program, you can now find that the value is UTD, which is assigned using this statement. Even now the variable college in this statement is a local variable, and the variable college in this statement is treated as a static variable. So therefore always remember that when a static variable is accessed, it has to be preceded by the class name. But when you are accessing a local variable, then that variable can be directly used. In this video, we will talk about different types of methods that can be defined in class. Let us create a class demo. We can have special methods, that is the constructors, which is defined using the init method and which takes in self as the parameter. We will not have any implementation for this method, so we will use a keyword pass. We have already seen instance methods, so let us define an instance method. Let us call it as A. Instance methods will always have at least one parameter, that is self. Since we are not having implementation for this method, we will use pass as the keyword. The other types of methods that can be defined are class methods and static methods. Let us look at class methods. We will define a method B, and as the instance methods have first parameter as self, in the same way the class methods should have at least one parameter, that is CLS. We will not write any implementation for this method as well, so we will use pass as the keyword. Now we will define static methods. Let us define a method C, and the static methods will not have self, neither it will have CLS. We will also have pass as the keyword. Now if you look at this class, we have an init method which is preceded by double underscore as well as succeeded by double underscore. Remember that every special method will be preceded as well as succeeded by double underscore. Next we have defined is a method A which takes in self as the parameter. So this is an instance method. Then we have a method B which takes in at least one parameter, that is CLS, and this is a class method. Class methods always has to have a decorator, that is a string starting with @. We explicitly have to provide class method. This is known as a decorator. We also have a method C which is a static method. Static methods will not have self or CLS as the parameter. We can use decorators for static method as well. So let's have @ with the string as static method. The decorator for class method is mandatory, whereas the decorator for static method is optional, and we do not have any decorators for instance methods. We have created this class as demo, and when we run this class, nothing happens. We created this class only to demonstrate how instance methods are created, how decorators are used to create class methods, and how class methods are created, as well as to demonstrate how static method decorator is used and how static methods are created. Let us take an example of a class which adds two numbers to demonstrate static methods. We will create a class demo and we will define a method add which takes in two parameters. Since we are creating a static method, this method will not use self as the parameter. We will have two parameters, that is x and y. And we will have a print statement prints the sum of two numbers, that is x plus y. To execute this method, we can create an object, that is d equal to demo, and then we can use d dot add and pass the parameters as 10, 20. Now since this is a static method, we will have a decorator, that is @ followed by static method as the string. Let us execute this program. You can find that we have the sum as 30, which is 10 plus 20. Since we have created the add method as static, we can call the add method without creating the object of the class. That is directly using the class name, for example demo.add. Then we can pass the arguments, let's say 10, 20. Let us execute this program, we get the same result. Now suppose if I do not have the decorator, we will remove the decorator and then let us try to execute this program. We get the same result. Since we are using the class name followed by the method name. But suppose if I create an object that is d equal to demo, and then if I use d.add and then pass the arguments as 10, 20, and when we execute this program we have a type error. And the description of the error is that the method add takes 2 positional arguments, 3 are given. This is because we have not used a decorator. When we have not used a decorator, the add method is treated as an instance method and the first parameter, which is x, is treated as a self parameter. Since x is self, we can only pass one argument because x is treated as a self which is provided by Python. But suppose if we use the decorator, that is static method, we will not have the error and we get the result, that is sum as 30. So this is how static methods can be defined in a class. Let us now look at the class methods. We will create a class demo and we will define a method add as a class method. Since it's a class method, it will take CLS as the parameter. We will have 2 more parameters, that is x, y. Let us have a print statement, print sum of x plus y. Now since this method is a class method, we need to provide a decorator, that is @ symbol followed by class method. We can create an object of this class, that is d equal to demo, and then we can call the class method, that is d.add, and passing the arguments as 10, 20. Let us execute this program. We get the result as 30. The class methods can also be directly accessed using the class name dot add, and then let us pass the arguments as 10, 20. Let us execute this program. You can find that we have the result as 30. And suppose if we remove the decorator, that is class method, and execute the program, we get type error. And the description says add method missing one required positional argument, that is y. Now this is because we have removed the decorator and this add method now is treated as a static method, which takes in 3 parameters and we are only passing 2 arguments. So it's mandatory to have class method as the decorator. Let us also look at another scenario. Let us create an object d equal to demo, and using d as the object we will call the method add, passing 2 arguments, that is 10 and 20. And let us consider that we do not have class method as the decorator. Let us execute this program. You can find that we get the result as 30. Now here add is not considered as a class method, neither it is considered as a static method. It is considered as an instance method and the first parameter, that is CLS, is treated as a self parameter. And the rest of the 2 parameters are passed as the arguments when calling the add function. So therefore we need to be very careful in defining static methods as well as class methods. In this video we will learn about getter and setter methods. Let us create a class student. The members of the class can be public members that can be directly accessible from outside the class, or the members can be private members. The private members are not meant to be directly accessed. The private members of the class begins with 2 underscores. To access private members, we need to use getter and setter methods. The purpose of these methods is to get, that is return, and set, that is assign, private instance variables of a class. The restricted access to private members allows the methods to control what values are assigned. This is one of the fundamental concepts of information hiding. that is the abstraction of object-oriented programming. Let us assume that the student class will have a private member or private instance variable as name. So we will define a setter method, and the setter method always starts with the first word as set. And since name is the private instance variable, we will use setName as the setter method. The first parameter will be self, and the second parameter let us use as n. We will use self since it's an instance variable and also a private variable. We will use double underscore as a convention to define private variables. So we will have self dot underscore underscore name and assign the value as n. Let us now create a getter method for the same private instance variable, and getter method starts with the word get. We will use name and pass the argument as self. This method will return the value of the private instance variable name. So we will use return self dot underscore underscore name. In the same way, let us assume that we have a private instance variable known as marks. So we will define the setter method for marks. Let us call it as set marks. We will have the first parameter as self and the second parameter let us use it as m. Then we will have self dot underscore. Let us have the variable name as marks, which we will assign the value from the parameter m. We will define the getter method, that is get marks, which will use only one parameter, and return self dot underscore underscore marks. So this is the setter and getter method for the private instance variable, that is name, and this is the setter and getter method for the private instance variable, that is marks. Now let us have a user defined method or the instance method, that is display, which takes in one parameter, that is self. We will have a print statement which prints the name. We need to use self dot underscore underscore name, as well as we will have another print statement, and let us pass the string as marks, and we will have self dot underscore underscore marks. Let us create an object of this class using s equal to student. We can now use setter methods to assign values to the private instance variables, that is name and marks. We will use s dot set name and then pass the value, that is let us pass John, and then we will use s dot set marks and pass the value as 85.25. Let us call the display method, that is s.display, and execute the program. You can find that we have the output name, which is John, as well as marks, which is 85.25. We have used the set name method, which consists of n as a parameter, and we are passing the string John, which is assigned to the private instance variable, that is name. And then set marks, we are passing the value as 85.25, which is stored in the parameter m and assigned to the private instance variable, that is marks. And then we are using the display method, which prints the value stored in the private instance variable, that is name and marks. Remember that the private instance variables are always preceded by double underscore. So therefore here we have double underscore name as one private instance variable and double underscore marks as another private instance variable. Now in the display method, instead of accessing the private instance variables directly, we can also use the getter methods. That is, we can have self dot get name, and then we can also have self dot get marks. Let us execute this program. You can find that you get the same result. In this video, we will look at how to pass objects as class members. Let us create a students class. So we will have class student. We will have the constructor, that is the init method. First parameter will be self. Then we will have name as a parameter, role as well as marks. We will create instance variables, that is self.name equal to assign the parameter name, then self.role equal to assign the parameter role, and self.marks and assign the parameter marks. We will have an instance method, that is display, which takes in only one parameter, that is self, and here we will have print student name and use the instance variable, that is self.name. We will have another statement, print roll number, and we will use the instance variable self.roll. We will also have print marks, and we will use the instance variable self.marks. So this is the student class, which has three instance variables, that is name, role and marks, initialized using the init method. And we also have an instance method, that is display, which has several print statements. We will create another class. Let's call this class as placements. Now this class will have its own init method. First parameter will be self. The second parameter let us use as company. And the third parameter let us use as package. And the fourth parameter let us call it as stud. We will define instance variables, that is self.company and assign the parameter company. We will have self.package and then assign the parameter package, as well as we will have self.stud and assign the parameter stud. This placement class will also have a display method, which is again an instance method, and here we will have a print statement with the string as company name, and then we will use the instance variable, that is self.company, which prints the company name. We will have another print statement with the string as package, and we will use the instance variable self.package. In the init method of the placements class, we have a parameter stud. This parameter stud will be an object of the students class, which is assigned to the stud instance variable of the placements class. So stud will be an object of the students class, and in the students class we already have a display method. So let us call the display method of the students class inside the display method of the placements class. So we will use self.stud, which is the instance variable, .display. Now remember that this is the display method which is defined in the placements class. But this display method is the display method which is defined inside the students class. So this statement is actually calling the display method defined in the students class. We will create an object of the student class, that is s equal to student, and pass the first parameter, that is the name, as John, the second parameter which is roll as 101, and the third parameter which is marks as 78.25. We will call the display method of the students class. Let us execute this program. You can find that we have the output displaying the information of the student. Now we will create an object of the placements class. So we will use p equal to placements, and then we will pass the argument as the name of the company. So let us pass del. The second parameter would be package. So we will pass, let's say, 48,000. And the third parameter, stud, is the object of the students class. So we have already created the object s of the students class. Let us pass this object s. And then we will call the display method of the placements class. Since the display method of the placement class is calling the display method of the students class, we will comment this line. Let us execute this program. You can find that when we are calling p.display, the display method gets executed, and the first statement in the display method is calling the display method of the students class. So therefore we have the first part of the output as the information of the student displayed through these statements, and then we have the statements print company name and package that is displayed here in the output. So therefore this is how we can pass objects, that is in this case we are passing the object S as the class member to another class, that is in this case it is placements, and we will be able to use instance variables as well as call instance methods of the other classes. In this video we will learn how to create inner classes. Let us create a class known as college. Let us have a constructor for this college, that is the init method, which takes in self as the parameter. We will have a print statement inside the init method of the college class. Let us print outer class constructor. We will now create an inner class inside the class college. Let us call this class as student. Inner class is nothing but creating a class inside a class. Sometimes it is also called as nested classes. Even for this class student, we will have its constructor using the init method. Let us use only one parameter, that is self. We will have a print statement, and let us print the string inner class constructor. Let us define an instance method, that is, let's call it as display S for student class. We will have self as the parameter, and then we will have a print statement which will print, let us say, student method. Let us also have an instance method for the college class. We will call this method as display C, and we will use self as the parameter. Let us have a print statement which will print college method. If you look at this program, the student class is an inner class which is defined within the college class. You can also observe that since student class is an inner class or it is part of the college class, it is indented, and even the methods, that is init method as well as display S method of the student class, is indented respective to the student's class. This method init belongs to the college class, as well as this method display C belongs to the college class, because these methods are indented respective to the college class. Let us now create an object of college class. We will have C equal to college. Now here C is the object of the college class, so we will be able to access the init method as well as the display C method. We will not be able to access the init method of the student class as well as display S method of the student class. So we can use C dot display C, and let us execute this program. You can find that when the object C is created of the type college class, the init method is implicitly called, and in the init method we have a statement print outer class constructor. So therefore the first line of the output is outer class constructor. Then we are calling display C method. So the display C method has a print statement, and we have the output as college method. Now if I try to use C dot display S, I will get an attribute error. So even though the class student is an inner class of the college class, we will not be able to directly access the methods of the student class. Now, to access the method of the student class, we need to create an object of the student class. Let us use S equal to. We cannot directly create an object of the student class. Since student class is an inner class, we need to create an object of the student class using the outer class object, that is C.student. Now using the object S, we will be able to call the display S method of the student's class. Let us execute this program. You can find that the first statement of the output, that is outer class constructor, is because we have created an object of the college class, and init method is implicitly called, and we have a print statement which displays outer class constructor. Then we are calling the display C method of the college class, which has a print statement which prints college method. Then we are creating an object of the student class using the outer class object. So once the object of the inner class is created, the init method of the inner class is implicitly called. And in the init method we have a print statement which prints inner class constructor. And then we are calling the display s method of the student class. The display s method of the student class has a print statement which displays student method. As we cannot access the methods of the inner class using the outer class objects, the same way we cannot access the methods of the outer class object using the inner class object. For example, we cannot access display c method, which is a method of the outer class object using the inner class object s. When we execute the program, we get an attribute error. We can also create an object of the inner class using the outer class name. For example, we can have s equal to college, which is an outer class with its constructor dot student. Always remember that the outer class name should appear before the inner class name. Then we will be able to call the display s method of the student's class. Let us execute this program. We get this as the output. Now here you can find this part of the output is because of these two statements, and this part of the output is because of these two statements. Now we are having the output as outer class constructor because of this part of the statement which implicitly calls the init method of the outer class, that is college, and then we are having this part of the statement which implicitly calls the constructor of the inner class. So this is how inner classes can be implemented in Python. We can have more than one inner class, as well as we can have nesting at different levels. In this video, we will talk about destructor methods in Python class. Let us create a class known as demo, and we will create an init method, and let us have a print statement in init method, and we will display the string as constructor called. This init method is a special method also known as a constructor. We will create a user-defined method. Let us call it as display using only one parameter. Let us have a print statement print. Let us pass the string as display method called. We will now create a destructor method. We will use def as the keyword, and as we are using a special method for constructor, the same way for destructor we have a special method which uses underscore underscore del underscore underscore, and this special method also takes in only one parameter, that is self. Let us have a print statement in the destructor, and we will have the string as destructor called. So therefore in this demo class we have a special method init which is also known as a constructor. We have an instance method, that is display, and we also have another special method known as del, which is also called as destructor. Let us create an object of this class. We will use d equal to and the class name, that is demo in this case. Let us execute this program. You can find that the first statement of the output is constructor called. This is because once an object is created, Python implicitly will call the constructor. As well as since this statement has completed its execution, that is the object is now no more in use, the Python is also implicitly calling the del method, which is the destructor. And in this method we have a print statement which displays destructor called. Therefore we are having the second line of the output as destructor called. Let us try to call the method display. Let us now execute this program. You can find that the first statement of the output is constructor called because we have created an object d using the class name, and this statement will implicitly call the constructor, that is the special init method. After calling the constructor, the object is still in use, that is we are calling the display method of the object d. So this method gets executed and we are having the statement as print display method called, which is displayed in the output. And after the display method completes its execution, the object D is no more in use, so implicitly the destructor or the special del method is called, where we have the statement as print destructor called and the last line of the output is the same. So therefore, as the constructors are called implicitly by Python, in the same way even the destructors are called implicitly by Python. The constructor is called when the object is created and the destructor is called when the object is not in use.